Today, we're going to talk about a really cool shift happening in artificial intelligence. What if I told you the future of AI vision isn't about building bigger, more monstrous models, but about getting the AIs we already have to work together like a dream team? Let's dive into this much smarter way for AI to see the world.
So when you look at this picture, your brain just knows. That's a cat, that's a pumpkin, there's a window in the back. You do it instantly without even thinking about it. But for a computer, understanding this open world with its infinite number of objects is one of the absolute biggest challenges in all of AI.
And this really is the heart of the problem, right? The massive challenge of teaching an AI to recognize anything and everything it sees just like we can. And in the world of AI, this has a very specific name. It's called Open World Object Detection. You can basically think of it as the holy grail for computer vision. It's about moving past a pre-approved list of objects, car, dog, tree, and getting to a point where an AI can identify, well, literally anything it comes across.
So to really appreciate why this new solution is such a game changer, we kind of have to look at the old playbook first. Let's see how researchers used to try and solve this problem and, well, why those methods just hit a wall.
For a long time, there were two main strategies. The first one was sort of like looking at the world through a peephole. The AI would crop out these tiny little regions of an image to figure out what they were, but that meant it lost all the important context from the rest of the scene. The other method was just brute force. Try to build a single, gigantic model from scratch and feed it billions of labeled image regions. So the bottom line is, neither of these was a great solution. One was missing the bigger picture entirely, and the other was just incredibly expensive, super slow, and often had to deal with messy, inaccurate data. Yeah, you can really think of this old-school training as just burning an insane amount of computing power and time trying to force one giant model to learn everything there is to know about our visual world. You just knew there had to be a smarter way to do it.
And this is where things get really interesting. This brings us to a brilliant new idea. What if, instead of trying to build one overworked do-it-all model, you could just assemble a dream team of AIs that are already specialists?
So, let's meet the players. On one side, you have the Segment Anything Model, or SAM. Think of it as the locator. It's an absolute master at finding where things are in an image, because it was trained on over 1 billion object masks. Then on the other side, you've got CLIP. It's the identifier, an expert in knowing what things are, because it learned from 400 million image and text pairs from the internet.
So this was the million-dollar question. Could you get these two experts to work together? Could you combine their incredible strengths without having to do all of that expensive, time-consuming retraining? Well, the answer turned out to be yes. And the solution is a brilliantly simple model called RegionSpot.
So how does it actually work? Well, this is the really elegant part, the way RegionSpot manages to combine the power of these two amazing models.
The first step, and this is the most important one, is to freeze both of those foundation models. What that means is all of their powerful pre-existing knowledge is totally preserved. No retraining needed. You don't mess with what already works.
And this diagram shows the solution perfectly. Instead of changing the experts, RegionSpot just trains this tiny, lightweight translator that sits right between them. This little module's only job is to learn how to connect the where information from SAM with the what information from CLIP. It basically teaches them how to speak the same language so they can collaborate.
And the result of this approach? It is absolutely staggering. I mean, look at this chart. The previous best model, this brute force giant called GLIPL, took 120,000 GPU hours to train. RegionSpot gets better results in just 200 GPU hours. That's not just a little more efficient. That is a 600 times leap in efficiency. It's a whole different ballgame.
Okay, so it's ridiculously efficient to train. That's great, but is it actually accurate? Let's take a look at the proof, because honestly, the results here are just as impressive. When they tested it on a dataset full of rare and really tricky objects, RegionSpot blew the old model, GLIPL, out of the water by an average of 13.1 points in accuracy. So for these tough, real-world situations, it's not just a little bit better, it is a lot better.
And that accuracy isn't just some abstract number. What it actually means, as the researchers point out, is that the model can pick up on subtle details that other models just completely miss. It can correctly identify tiny objects or tell the difference between two things that look almost identical.
Here is a perfect example. The old model, GLIP, looks at this image, gets confused by the shape, and calls it a lantern. But RegionSpot,
with its much better understanding of context, sees it for exactly what it is, a fire plug.
And check this one out. Glip sees a small, round, yellowish thing next to a dog, and his logic is tennis ball. I mean, it's a reasonable guess, but it's wrong. RegionSpot correctly identifies the object as a lemon, probably because it's using more nuanced info about its texture and where it is in the scene.
So, what does this all mean? Why is this more than just another small step forward for AI? Why is this such a big deal?
Well, this really is a major paradigm shift. For years, the path forward in AI was just assumed to be build bigger, more expensive models. RegionSpot proves that the future is actually about cleverly combining the powerful tools we already have. We're moving from brute force construction to elegant collaboration, and that's going to make AI development way faster, cheaper, and a lot more effective.
The takeaway here is pretty clear. We are moving out of the era of the computational sledgehammer and into the era of intelligent assembly. RegionSpot is the proof that in AI, synergy and smart design can beat raw power hands down. It's about